The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Hello children, so how are you all? Hope you are all considering the forthcoming exams in its true spirit. But don't get over-tensed. Consider it as just another program. Gurukulam is always full of programs, right? So this is also another program just to check whether whatever we have taught has reached you fruitfully. Okay? So do well, all the best, give out your best performance. Okay? Now, shall we move into our topic? Last week, I just gave an introduction of periodic table. What is the necessity for a periodic table? Isn't it? We are arranging elements in an appropriate way. Okay? We were into the history of classification of elements, right? The first classification was done by Lavoisier. He classified the then existing elements, that is the 30 elements, into metals and non-metals. But the limitation was he was not able to categorize some of the elements into both the groups. Why? Because these elements exhibited the properties of both metals and non-metals. The second classification was done by Dobrina, isn't it? He classified the elements into triads. What are triads? Triads are a group of elements. How many elements? Only 3 elements. And what is the peculiarity of this type of classification? Yes, when you add the atomic mass, that is a mass number of the first and the third element, and if you calculate the average, that will be the atomic mass or mass number of the second element. That was Dobrina's classification. Again, there was a limitation. He was not able to classify some elements into these groups, that is triads. Okay. The third classification was done by John Newlands. What did he do? He arranged elements according to the octaves. So he understood, he showed that, he proved that when elements are arranged in octaves, the element coming under one group, that is the first and the 8th element, exhibited same properties, isn't it? So this was Newland's way of classifying the then existing elements. Again, the limitation was he was not able to categorize elements with higher atomic mass into these groups. Okay? So these were the 3 classification we understood last week. Today, we are going to discuss about a Russian scientist. He is Dmitry Ivanovich Mendeleev. Dmitry Ivanovich Mendeleev, what did he do? He classified the then existing elements. How many elements were there? There were 63 elements. Okay? So what did he do? He arranged all these 63 elements in a table. So Mendeleev was the first scientist who arranged the elements in a table. Okay? So he is also called as the father of the periodic table. Why? Because Mendeleev was the first scientist to arrange elements in a table. Okay. How did he arrange these elements? Well, these elements are arranged in the increasing order of their atomic masses. What is atomic mass? Mass number. Okay, atomic mass and mass number both are same. Okay, so he arranged the then existing 63 elements on the table according to the increasing order of their atomic masses. Okay, so when he arranged all these 63 elements, he found out that elements coming under the same group exhibited similar physical as well as chemical properties. Understood? So based on this, he proposed the periodic law. It is called as Mendeleev's periodic law. What does Mendeleev periodic law say? The physical and chemical properties of elements are periodic functions of their atomic masses. So this is Mendeleev's periodic law. Okay? So it says that the physical and chemical properties are getting repeated if elements are arranged in the increasing order of their atomic masses. Now shall we see the Mendeleev's periodic table? Yes, this is Mendeleev's periodic table. You can see. You can see how many groups are there? 1, 2, 3, 4, 5, 6, 7, 8 groups are there. Okay. The vertical columns are called as groups and the horizontal rows are called as periods. So you can see 8 groups. And how many periods are there? 6 periods in Mendeleev's periodic table. Yes. So what did Mendeleev do? So in Mendeleev's periodic table, what are the important points we discussed? The first one was elements were arranged in the increasing order of atomic mass. The second point is periodic law. What does Mendeleev's periodic law say? When elements are arranged in the increasing order of their atomic mass, they show similar physical and chemical properties. Okay, so that is called Mendeleev's periodic law. What was the third point? The vertical columns are called as groups. And the fourth point is the horizontal rows are called as periods. So these are the 4 important points in Mendeleev's periodic law. Okay? Then now we will see what are the advantages of Mendeleev's periodic law. Okay? There were 3 important merits in Mendeleev's periodic law. What were the 3 merits? Merit number 1. When elements are arranged in the increasing order of the atomic masses, it was seen that elements coming under one group, there were 8 groups, right? So each group elements exhibited similar physical as well as chemical properties. So what? Now the study of elements in chemistry was much more easier for other scientists. So that is the first merit. The second merit was earlier when Mendeleev was arranging elements in the periodic table, the atomic mass of beryllium was 14. Later on, he redetermined when he placed element in 14, in column 14 or in the place of 14, he saw there was some mistake. So he again studied the atomic structure of beryllium and redetermined, changed the atomic mass of beryllium from 14 to 9. So now beryllium has got a correct position in the periodic table. The atomic mass of beryllium was changed from 14 to 9. This is just an example. Many examples of elements were there where Mendeleev changed the atomic masses. So this is just one, beryllium is just one example. Okay. Now what was the third merit? Children, if you see the Mendeleev's periodic table, yes, this is Mendeleev's periodic table. You can see lot of empty spaces there. Why are some places left empty? Yes, these places were left empty for the future discovery of elements. Mendeleev have left the space vacant so that when the future scientists they they discover an element which belongs to the same group, they can place the element in that vacant places. So, it was a great noble act of Mendeleev, right? So, he has given space for future scientists also. So, in Mendeleev's periodic table, we can see vacant spaces. Why has he left the spaces vacant? For the future discovery of elements. So, these are the three merits of Mendeleev's periodic table. Now, anything which has a merit will always have a demerits also, isn't it? So, now we will move to the demerits or disadvantages of Mendeleev's periodic table. Children, now we will move to the demerits or limitations of Mendeleev's periodic table. So, the first limitation is, what did Mendeleev say about the elements in periodic table? He said that these elements coming under the same group, that is vertical column, elements coming under the same group will always exhibit similar physical and chemical properties. But there was large differences in elements coming under the same group. For example, copper, silver, they were showing vast difference in their properties when compared to other elements in the same group like sodium, potassium. What was the first difference? Sodium and potassium are very soft metals, as you know, whereas copper, silver, they are all hard metals. That was one major difference. Likewise, many physical and chemical differences were seen between these elements coming under the same group. That was the first limitation. The second limitation was, what was it? Hydrogen. You can see in Mendeleev's periodic table, you can see that beneath hydrogen there is lithium, sodium, potassium, copper, rubidium, silver, cesium and gold. Isn't it? So, is hydrogen a metal? Not at all, isn't it? It is neither an alkali metal. So, you will learn all about metals and alkali metals in forthcoming classes. So, hydrogen is neither a metal nor a alkali metal. So, why is hydrogen placed in that group, in the same group of metals? So, that is a big question. Hydrogen does not have a proper place. So, that was the second limitation. But children, the same problem exists even now. The modern periodic table which we are following, in this hydrogen is having the same position. Till now, hydrogen does not have a proper position. So, in Mendeleev's periodic table, that was the second limitation. Hydrogen has not got a proper place because it is placed in the same group of metals like sodium, potassium, rubidium, cesium. So, hydrogen does not have a proper place. That was the second limitation. The third limitation was, how did Mendeleev arrange the elements in periodic table? According to the increasing order of their atomic masses. But this was not followed in some cases. So, we will see that in the Mendeleev's periodic table. Yes, you can see cobalt, nickel, tellurium and iodine. They do not follow this rule. What was the rule? To arrange elements in the increasing order of the atomic mass. So, you can see cobalt, it is 58.93, nickel it is 58.71. So, we should come before nickel cobalt should follow nickel, isn't it? But here it is just the opposite. In the case of tellurium and iodine also, tellurium has atomic mass 127.60, whereas iodine has 126.90. So, actually tellurium should follow iodine. Iodine should come first and then tellurium should be behind iodine. So, this rule is not properly followed in the case of cobalt and nickel, tellurium and iodine. So, such mistakes were seen in Mendeleev's periodic table. So, these were the demerits in Mendeleev's periodic table. So, I hope you have understood what is Mendeleev's periodic table, what are the merits and what are the demerits, isn't it? So, before winding up the class, let me give you a quick recap. What is Mendeleev's periodic table? Yes, Mendeleev was a Russian scientist who first formulated a table to arrange the then existing 63 elements. Okay, so he arranged the elements according to their increasing order of their atomic masses. Based on that, he proposed a law. It was called as Mendeleev's periodic law. There were horizontal rows. Horizontal rows are called as periods, and vertical columns, 8 columns were there. They were called as groups. What were the merits of Mendeleev's periodic table? Yes, when he arranged the elements in their increasing order of their atomic mass, the elements coming under the same group, similar group, okay. For example, if it is first group, all these first group elements exhibited similar physical and chemical properties. So that was the first merit. Second advantage was he redetermined the atomic masses of some elements which were wrongly determined. So he, through experiments, diffraction experiments, he found out that some atomic masses of some elements were wrongly determined. He changed the atomic mass of those elements. Example was beryllium. We have studied only one example, beryllium. Beryllium's atomic mass was changed from 14 to 9. What was the third merit? Yes, he has left empty spaces for the future discovery of elements. So limitations, what were the 3 limitations? Number 1 was elements with a large difference in their physical and chemical properties were placed in similar groups. For example, sodium and potassium. These are soft metals, whereas copper, silver, they are hard metals. So all these were placed in one group. So there was variation in the physical and chemical properties of large variations in the physical and chemical properties of these elements. Okay. So what was the second disadvantage? Hydrogen has not been given a proper place in Mendeleev's periodic table. Why? Because it is placed just above the metals like sodium, potassium, lithium, isn't it? So hydrogen is not given a proper place in Mendeleev's periodic table. And what was the third limitation? Yes, he arranged the elements according to the increasing order of their atomic masses. But it was done wrongly, isn't it? It was not, these elements were not given proper position. Some of the examples were cobalt and nickel, tellurium and iodine. So I am going to wind up this session, children, as you are facing the exams next week. So all the best for your exam. Perform well. Okay? Bye, children.